Hello and welcome back. The first lesson we're going to talk about here, first semester, is in Unit 6, Section 1. It's called Operations on Functions. Now, what's important here, one of the things that's important here is the word functions. Everything you see today will be in function notation. So, for example, f of x, remember, is not f times x. It's the input or the domain is what you see inside the parentheses, or in other words, it's what you plug in to the equation. Okay, so continuing on, okay, we have four operations here: addition, subtraction, multiplication, and division. Under the definition column, you have just the function notation look, okay, at all four operations. Now, notice for all of them, there's two different ways to look at it. For addition, you could write it this way, or you could write it this way. And you are responsible for understanding that both of those mean the same thing. For subtraction, you could write it like this, or you can write it like that. And again, you're responsible for understanding that those two are the same thing. Now, with subtraction, order is important. So whichever function comes first, stays first. And then whichever function comes last, stays last. For multiplication, you probably see that dot there, meaning multiply. They could either look like this or like that. And then division, you also have two different looks. You have this, and you have this. Again, division order is important. Whichever function is the dividend, stays the dividend. Whichever function is the divisor, stays the divisor. One small note with division, okay, is that whatever you're dividing by, in this case, g of x, cannot equal 0. Because, remember, division by 0 is undefined. Now, let's go ahead and let's go through four different examples. All right? You're given the fact up here at the top that f of x is equal to 2x, and that g of x is equal to negative x plus 5. Okay, so the first example, addition f of x plus g of x. Well, f of x is 2x plus g of x is negative x plus 5. Now, I put it in parentheses first, okay, simply because I had a binomial. I had two terms, and I can show you, all right, pretty straightforward, what the two different functions are. Now, when I go to actually simplify this, I'm going to drop the parentheses. Plus a negative is minus, and it's going to look like that. Now this goes back to day 1 in August. Just combine your like terms. 2x minus x is x plus 5. There's our answer. Okay? When we're dealing with functions, get away from the belief that everything has to be a number. You could have expressions as answers like we do here. Okay, let's move on to subtraction. F of x minus g of x. So f of x is 2x minus g of x. Well, g of x, again, is negative x plus 5. Now, be careful with subtraction. If you have a minus sign directly in front of a set of parentheses or of a quantity, you have to distribute it through that quantity. So this becomes 2x minus a negative is plus x. But we also, remember, have to distribute to this sign as well, minus 5. Okay, so this time when we simplify and combine our like terms, 2x plus x is 3x minus 5. And that is our answer for the subtraction example. Multiplication, f of x times g of x, f of x 2x times g of x times negative x plus 5. Okay, sometimes you'll just have simple multiplication, coefficient times coefficient, or variable times variable. Other times, like here, you're going to have to use the distributive property, or you might have to FOIL. So our distributive property, 2x times negative x, is negative 2x squared. 2x times 5 is 10x. Now, when we take a look at that, we're always looking for like terms. There are not any here. because the variables have different exponents. That's our final answer. Okay, and then lastly, down here with division, f of x divided by g of x. F of x is 2x divided by g of x, negative x plus 5. Okay, now, there's no actual division that we can do here. Okay, we're going to leave it like it is. The one thing that we do have to show, though, is where our denominator is undefined. Or in other words, what's the number we would plug in there to make the denominator 0? Because in reality, we really can't use that number. So how you do that is you take that denominator, in this case negative x plus 5, and you set it not equal to 0. And what we're going to do there is we're going to go ahead and solve for x. Subtract 5, so negative x does not equal negative 5, and then multiply by negative 1, so x cannot be 5. The specific term for that number, okay, for the 5, is what we call the domain restriction. The domain restriction. Okay, and that was the same thing over here. This g of x cannot equal 0. That is your domain restriction. The domain always starts off with all real numbers, and then depending on what kind of operation you have, you might have to restrict some values. Okay, now we're going to do some examples. We are given both what f of x and g of x are. They have changed from the chart above. F of x is equal to x squared minus 4. G of x is equal to 2x plus 1. We're going to take those two functions, and we are going to add, subtract, multiply, and divide them. Okay, so the first one, number 1, we're going to add. Okay, now remember, this is the same thing as f of x plus g of x. Now let's actually go through and talk about all four, what all four of them would look like written in their different form. This is actually f of x minus g of x. Number 3, this is actually f of x times g of x. And then number 4, this would be f of x divided by g of x. Okay, now domain restriction, g of x cannot be equal to 0. Now let's go through and let's actually do each example. Okay, so number 1, right? F of x is x squared minus 4. And we're going to add to that g of x. G of x is 2x plus 1. Now, if I put these around each function, that's fine. But understand in this case there's no subtraction, okay? I'm not distributing a negative sign, so they're really not needed, right? Let me get that back in there, right? And at this point we're just going to combine our like terms. X squared stays x squared, 2x stays 2x, and then negative 4 plus 1 would be negative 3. This would be my result, okay? That would be the answer to number 1. Now number 2 is going to be a little bit different because I am going to have a minus sign. So f of x is x squared minus 4 minus g of x, which is 2x plus 1. Okay, now notice I didn't put parentheses around f of x because they're not needed. But here I do have to distribute this minus sign through. Okay, so this minus sign here and there. Okay. So the result of that, I would have x squared minus 4 minus 2x minus 1. And when I combine my like terms, x squared minus 2x, and then negative 4 minus 1 is negative 5. Be my answer to number 2. Now, number 3. Okay, number 3. F of x times g of x. F of x is x squared minus 4. and g of x is 2x plus 1. Now, because I knew what the functions were, I anticipated that I'm going to have to FOIL. I've got a binomial times a binomial, so I put my parentheses in there right away. Okay. Now we FOIL, remember it's first outside, inside last. So 2x cubed plus x squared minus 8x minus 4. Okay, first outside, inside last. Combine any like terms, which usually there are. Here there's not. FOIL is the last step. You have your answer. This is the answer to number 3. Okay, and then finally in this example, number 4, f of x divided by g of x. Okay, f of x is x squared minus 4. G of x is 2x plus 1. Now, we're not actually going to do any division. But what we do have to show is where the domain is restricted. Okay, so we'll change colors here. All right, you take your denominator and you set it not equal to 0 and solve for x. Subtract 1, divide by 2, x does not equal negative 1/2. Okay, so there's really 2 parts to this. The domain restriction, x cannot be equal to negative 1/2, and then also what f of x divided by g of x is. And that's the answer to number 4. Okay, your next task, all right, after you've copied obviously the chart up above, and then these 4 examples down just as I have, is you are going to, on your own, work through 5, 6, 7, and 8. When you're done working through 5, 6, 7, and 8, you are going to pause the video, and you are going to come up to my desk, and I will show you what your answer should be. If you have an incorrect answer, I will send you back to your desk to fix it, and you're going to come up, okay, and show me your work that got you the correct answer, okay? I will put a mark on your page, okay, that does show that you have completed all 4 of these correctly, and then you can move on to the rest of the video. Okay, so go ahead and work through 5, 6, 7, and 8 at this point. Again, when you're done with all 4, not one at a time, when you're done with all 4, bring them up to my desk and I will check them for you. Okay, on the back side of section 6.1 is a different way to combine functions, which is called composition of functions. It's not necessarily addition or subtraction or multiplication or division. This is just an entirely different way to combine them. Okay, oftentimes we are plugging one function into the other. Now, up at the top where it does say composition of functions, okay, it shows you, okay, right here, one way to write it, with an open dot. Okay, that's not multiplication. Notice the dot is not colored in. That means we are composing the functions f of x and g of x together. Another way to write it is what you see here. That's probably more common, even though your next 4 examples will show this with the open dot. Okay, but how we say that is we say it like it's written right there at the top of your notes. F of g of x. Okay, f of g of x. What this composition of functions is actually telling you to do is plug g of x into f of x. Okay? Now, let's show that here in number 9 using the following 2 functions. Okay? Using this f of x and this g of x. So number 9, we have f of g of x. What this is telling you to do, I'm actually going to write it out this time, is to plug g of x into f of x. Okay. Now how do we do that? Basically what you're going to do is take the whole function g of x, which is 4 times x, and plug that in for x in the f of x function. So let's write the f of x function down. Okay, it is 2x minus 5. Now then what we're going to do is we are going to take this 4x and plug it in for this x right here. We are substituting, I've been using the word plug in. We're going to plug 4x in for x. Okay? So what it's going to look like then, when I do that, is 2 times 4x gets plugged in. It replaces the x. I don't have a double occurrence of that x. It's replacing that x. Minus 5. And then from here, we're just going to simplify. We're going to do the order of operations, or we're going to combine like terms. Okay, so what do we have here? We have 2 times 4x, which is 8x, minus 5. And there's your answer right there. 8x minus 5. Okay, so that's our first composition. Okay, let's move on and let's do some other ones. Okay, number 10, we have an open dot that tells us it's a composition, but this time, g and x are in the other spot. So order is important with compositions. This time in number 10, this is telling us to plug f of x into g of x. Okay, so order is important. We're going to plug f of x into g of x. Okay, so we're going to write g of x first. G of x is 4 times x. So what we're going to do is we are going to take this 2x minus 5 and plug it in for x. So the function will now look like this. 4 times 2x minus 5. Okay. This time we have to use the distributive property. Okay. 4 times 2x is 8x. 4 times negative 5 is negative 20. Probably a little confused at this point, and that's understandable. Compositions of functions are not the easiest thing, but it does take practice. You will have to do, if this is a hard concept for you, you're going to have to do more than usual to understand and be able to do these. Okay? And that's okay. All right, take a look at 11. A little bit different. F of x. So g of x does not play a part in this particular problem. We're going to plug f of x into f of x. Right? So f of x is 2x minus 5. Okay? We are going to replace x with f of x. Well, f of x is 2x minus 5. And then we're going to go ahead and we're going to distribute. We're going to get rid of parentheses. We're going to simplify. We're going to combine like terms. We're going to do all of that. So distribute, I get 4x minus 10, and I still have this minus 5. Combine your like terms, 4x minus 15. F of x. Okay, and then finally number 12, g of x. We're going to plug g of x into g of x. G of x is 4x. Well, we're going to plug 4x in for x. So 4 times 4x. Multiply those together. You get 16x. Okay, now in 13, 14, 15, and 16, we're going to move on to some compositions that tend to be a little bit simpler. We started off with what I think is the most complicated types of compositions, and we're going to move things that are a little bit easier. So notice the difference in 13, 14, and 15. 13, f of g of 3. The difference is right here. This time, I have a number. Up here, I had a variable. Okay? So right away, we see that our compositions are going to be a little bit different. Now, what this means is, in number 13, it means that we are going to plug 3 into G, get a result, and then that result we're going to plug into F. Okay? So you work right to left. Okay? So we're going to start off with G of 3. Okay? So G of 3 is equal to, okay? And our functions have changed a little bit. Here's G of x. Here's F of x. Okay? So G of 3 is 3 squared, which is equal to 9. Okay. Now, what we're going to do with this 9 is we're going to plug that into f of x. Okay? So f of 9 is equal to 2 times 9 minus 3. 18 minus 3, which is equal to 15. 15 is your final answer. A little bit different than the previous set of problems we did. Okay, take a look at 14. Now we have g of f of 3. Okay? This time, and order is important with compositions, we are going to start with plugging 3 into f of x. So f of 3 is equal to 2 times 3 minus 3, which is equal to 6 minus 3, which is 3. Okay? And then we are going to take this 3 and plug it into g. So g of 3 is equal to 3 squared, which is 9. Okay? And 9 is your final answer. To avoid any confusion looking back as to what the final answer is, I'll highlight it. Is your final answer there? Is your final answer here? Okay, number 15. Okay, number 15, we're going to plug negative 5 into g first. Okay, so g of negative 5 is equal to negative 5 squared, which is 25. Now we are going to take that 25 and plug it into f. So f of 25 is equal to 2 times 25 minus 3, which is 50 minus 3, which is 47. So our answer to 15, again I'll highlight it, is 47. Number 16, g of f of negative 5. We're going to plug negative 5 into f first. So f of negative 5 is equal to 2 times negative 5 minus 3, negative 10 minus 3, which is negative 13. We're going to take that negative 13 and plug it into g. So g of negative 13 is equal to negative 13 squared, 169. Final answer. So if we go back and look at the 8 problems we just did, 9 through 12 are compositions where you're plugging a variable in. Okay, or in other words, you're plugging an entire function into a function. The last 4, 13, 14, 15, and 16, we are plugging a value in. And then the result, we are plugging into the other function. Okay, so 2 different types of compositions. All right, so this last set, 17 through 24, okay, again, we're doing compositions, but they're a little bit different because this time our functions are given to us as ordered pairs. There's f of x. There's g of x. Okay, now, to understand how this works with function notation, one example I'm going to do over here to the right that isn't related to the problems, or is not one of the problems we're going to do over here. It's just kind of a standalone type deal so you understand how the ordered pairs work with function notation. Okay, let's talk about this ordered pair right here. Okay, now, this is the function g. Okay, talk about the ordered pair 9, 0. Okay, so what you've got going on here is f of 9 equals 0. Your x-coordinate is 9. If you plug that into your function, you get 0, the y-coordinate. Okay, remember, function notation, if you write it out completely, is another way to say x-coordinate, y-coordinate, input, output. And ordered pairs, x-coordinate, y-coordinate, input, output. Okay, it's the same thing, just written a little bit differently. Okay, so for these next problems, notice there's nothing really written as to what the problem should be. Okay, so I'm going to have to write those in for you. Okay, so we'll start off first with 17 through 20. f of g of x. Okay? What this means is f of g of, and we're going to use every x coordinate in our g function. So the first one would be of 8. The second one, f of g of 5. The third one, f of g of 10. And the fourth one, the one we were kind of talking about, f of g of 9. Okay? Okay, so these are similar to the 4 we just did where we're plugging a number in. Okay? So there's going to be kind of a domino effect here. There's going to be a cause and effect. Okay? So there's going to be 2 steps with each problem. Okay? The first step is, what's g of 8? Okay? So if we look at the blue g function up here, when 8 is my x-coordinate, 15 is my y-coordinate. For the second one, g of 5. When 5 is my x-coordinate, 1 is my y-coordinate. G of 10. When 10 is my x-coordinate, 14 is my y-coordinate. 20. When 9 is my x-coordinate, 0 is my y-coordinate. Okay? Then we are going to now jump to the function f. And we're going to use the y-coordinates of my g function and plug those into my f function. So looks like this. Okay, we're going to use these numbers now. We're going to plug these into f of x. So f of 15, what does that equal? F of 1, what does that equal? F of 14, what does that equal? And then f of 0. So remember, these are x-coordinates. Well, what's the y-coordinate that goes with them? So if we look at the function f of x, when 15 is my x-coordinate, 11 is my y-coordinate. When 1 is my x-coordinate, 8 is my y-coordinate. When 14 is my x-coordinate, 9 is my y-coordinate. And then finally, when 0 is my x-coordinate, 13 is my y-coordinate. Okay? So, how do we write our answer? Well, if we go back to the first things we wrote, which was in black over here, f of g of 8 is equal to 11. This guy. F of g of 5 is equal to 8. That guy. F of g of 10 is equal to 9. From there. And f of g of 9 is equal to 13. That's from there. Okay? Okay, now, you'll notice that 21 through 24 have appeared on your screen. Where I got those is now we've changed our composition to g of f of x. So these numbers right here are the x-coordinates, right, in my function f of x. Okay, what you see up there in yellow. 1, 0, 15, and 14. Okay? So what we're going to do then, okay, you can pause the video right now if you want to jot all those down before moving forward. I'm going to go through and I'm going to find out what the answer is for each of these. Okay, now something a little bit different is going to pop up here. And that in one or more of these, the empty set is going to be our solution. And I'll talk about why, if that happens, or when that happens. Okay, so the first one here. All right, remember, you start with f of 1. So when my x-coordinate's 1, my y-coordinate is 8. Okay, and let me move the up here. Okay, take a look up here. Well, my x-coordinate's 1, my y-coordinate is 8. Okay, then we're going to plug 8, okay, into my function g of x. Okay, so g of 8. Okay, and so I'm going to look up here. When my x-coordinate is 8, my y-coordinate is 15. Okay, so 21, g of f of 1 is equal to 15. Okay. Let's move to the next one, g of f of 0. So f of 0 is equal to, if I look up here, well, my x-coordinate is 0, my y-coordinate is 13. So that takes us to g of 13. And what is that equal to? So if we look at all my ordered pairs, I do not have an x-coordinate that's 13. It doesn't exist. So here is where a solution is, the empty set. It doesn't exist. And I cannot create it into existence. Okay, so my answer is the empty set. 23 and 24 I'll do together. So f of 15 is equal to 11, and f of 14 is equal to 9. Okay, so that takes us to the g function, so g of 11, what's that equal to? And then g of 9, what's that equal to? So if I look up here, do I have an x-coordinate that is equal to 11? Sure don't. So again, for this one, it doesn't exist, so it's the empty set. The answer here, empty set. Does g of 9 exist? Do I have an x-coordinate of 9? I sure do. There it is. And when the x-coordinate is 9, my y-coordinate is 0. The answer here is 0.